Okay, I'm Brennan and I'll be doing equilateral triangles. So first let's go over the properties of an equilateral triangle. We know that all sides are congruent and then all angles are congruent. And because a triangle has 180 degrees and all three angles are congruent, that means all angles would equal 60 degrees. So let's go to problem 1. A triangle has a side length of 8, so find the area. Now these tick marks mean all the side lengths are equal, so that means it's an equilateral triangle. And now that we have our side length of 8, we can plug it into our equilateral triangle area formula of side squared square root of 3 over 4. Now when we plug in the 8 for s, we get 8 squared square root of 3 over 4, which would give us 64 square root of 3 over 4, which would come out to be 16 square roots of 3 as the area. Now here's problem 2. We'll save this for class, but if you choose to, you can stop and work it out yourself. So let's go to our challenge problem. BC is 32, the area of the triangle BEC is 48, HI is 15, and the angle of ECD is 60 degrees. We have to find the area of triangle FEG. So first, we have to find HE. Now we know that our triangle formula is base times height over 2, so we can plug in the area for BEC, 48, equals the base of 32 times whatever HE is, so we'll plug that in as x over 2. Multiply by 2, we'll get 96 equals 32x, and divide that by 32, and we get 3 for x. And so now we can find EI, 15 minus 3 is 12. So let's put that into our triangle, and now let's go over to this trapezoid for a second. We know that opposite angles in a trapezoid are supplementary, which means they equal 180 degrees. So 180 minus 60 gives you 120 degrees. We also know that linear pairs equal 120 degrees, so 180 minus 120 is 60 degrees. And so we can come down here, and we find that this triangle right here is a 30, 60, 90 triangle with 12 across from 60. So what we have to do is we have to do 12 over root 3 equals root 3 over 3, root 3. We cross multiply, so 12 root 3 over 3, which would give us 4 root 3 as half of one of our side lengths. Multiply by that 2 to get our side length of 8 root 3, and then we'll plug it into our equilateral triangle formula. Area equals 8 root 3 squared, or side squared, square root of 3 over 4, which would give us 64 times 3, which is 192. So we have 192 root 3 over 4, which gives us an area of 48 root 3.
Okay, I'm Aaron, and I'm going to be doing Heron's theorem. So just note that this theorem has two parts, and you use it on a non-isosceles or equilateral triangle. So I'm actually going to do part 2, and what you're going to do is this solves for an area of a triangle. So area equals the square root of s minus a, s minus b, s minus c. Okay, you multiply all those by each other. Now you're probably wondering how we find s. So that's part 1. S is going to equal a plus b plus c over 2, and those are all lengths of the triangle, or side lengths of the triangle. So this is going to be a. On practice problem 1 is what we're going to do right now. And this is going to be a, this is going to be b, and this is going to be c. Okay, so here's how we're going to solve for this. We're first going to plug it into our part 1 formula. So it's going to be 3 plus 4 plus 5 over 2, which is equal to 12 over 2, or 6. So we're going to plug that into our part 2 formula. A equals the square root of 6, 6 minus 3, 6 minus 4, and 6 minus 5. Multiply those by each other, and it simplifies down to 6 times 3 times 2 times 1, or the square root of 36, making it easy, and a equals 6, because 36 is a perfect square. Okay, now moving on to our challenge problem. This one's just going to be a little bit harder. So how this is going to work is, if you can see, this is a 30, 60, 90 triangle, so this is going to be 3, and this is going to be 3 root 3, making things just a little bit harder. So what we're going to do is we're going to plug it into our part 1 formula, which is going to be 6 plus 3 root 3 over 2, which simplifies down to 9 plus 3 root 3 over 2. Now bear with me, it's going to get a little long. So we have the square root of 9 plus 3 root 3 over 2 times 9 plus 3 root 3 over 2 minus 3 root 3 square root of 9 plus 3 root 3 over 2 minus 3, and 9 plus 3 root 3 over 2 minus 6. So what we're going to do is we're going to plug that all into the calculator, careful over your parentheses, and it's all going to simplify down. So we are going to get about, this is all rounded, we want a rounded final answer. We're going to find 11.59 times 6.4 times 8.59 times 5.59. Now that simplifies or multiplies to about a square root of 3,561.79. Plug that into your calculator, and you're going to get about 59.68. Okay, and that's your final answer.
Okay, so hi, I'm PJ, and I'll be working out isosceles triangles. So here's the first one. It's just going to show you the properties of the isosceles triangle, and as you can see, we have a lot of food to explain it. So here in our isosceles triangle, these cashews show the congruent sides. So in an isosceles triangle, the left side is congruent to the right side, and this licorice bisects the triangle, this line, right in the middle. So because it bisects it, this creates two congruent angles right here on the left and the right, and also a 90-degree angle on the left and the right, represented by the marshmallow. And also these cashews show that this left side is congruent to the right side. And also, because it's an isosceles triangle, these two sides are congruent to each other already. So now let's try to find the area of the isosceles triangle. So this side's 10, this side's 8. So because it's a 3, 4, 5, 6, 8, 10, this is going to be 6. So we can find that that's 6. So since we're trying to find the area, we're going to do base times height. So we know that since this side is congruent to this side, this is going to also be 6. So then 6 plus 6 equals 12. So 8 times 12 equals x, all divided by 2, because it's a triangle. So 8 times 12 equals 96, divided by 2 equals x. So 96 divided by 2 equals 48. That's the area. Okay. So now that we know the properties of it, let's go on to the second problem. It's going to be a little bit more difficult. We're also finding the area of the isosceles triangle, this one. So as we can see, this is a right triangle. So this is the right angle, and this line bisects it because this side is congruent to this side. So we know that that's 4, and since it bisects it, this is also 90 degrees. So if that's 90 degrees, and that's 45 degrees because this bisects it, that's also 45 degrees. So that's 45, 45, 90. So that means that this is proportionally, this is square root of 2. That's 1. This is also 1. So then we just set up a proportion. So 4 over square root of 2 equals x over 1. So 4 times 1 equals 4, obviously. Then so it's 2 square root of 2 x. So then we just bring that over. So 4 over square root of 2 equals x. So that finds us this. It also finds us this. So now, since we're trying to find the area of the whole entire triangle, we put 2. So 4 square root of 2. Sorry, this is all 4 over square root of 2. 4 over square root of 2. And 4 over square root of 2. So now, since there's 2 of them, we have 8 square root of 2, 8 over square root of 2, times 4 over square root of 2, over 2. This is all in parentheses because we do it first. Equals x. So 8 times 4 equals 32. And then times square root of 2 times square root of 2 equals 2. So then that's all over 2 in parentheses. That's over 2 equals x. And so 32 divided by 2 equals 16 over 2 equals x. And so that equals 8.
And here's the answer to number 2 for Brennan's, for those of you who tried it.